Okay, let's continue with letter D. And we're going to see that letter D actually works out the same way that letter C worked out. The first thing we're going to do, we're going to note that I'm not going to put givens in here, but I'm just going to note that I'm given that triangles AED and CEB are congruent triangles. So what I can do is I can start by saying that segment AD is congruent to BC by CPCTC. They're corresponding parts of congruent triangles, so they have to be congruent to one another. Number two, then, is a little more complicated. Now I have to look for something that I can use here. I'm not going to be able to use AB and CD because they're not parts of those triangles. So the sides one is out. And I don't know any whole angles of the parallelogram. I only know this part of an angle here and this part of an angle here, right, within the triangles. Maybe there's something there. I don't see it. What I do see is I can state that angle EDA is congruent to angle EBC. This angle here is congruent to this angle. But wait a second, these are all, because, and that's, by the way, that's by CPCTC, right? Because these are corresponding parts of congruent triangles. And then if these are alternate interior angles. So again, and another step that I didn't do in the previous one, I could state that these are alternate interior angles by the definition of alternate interior angles. It'd probably be a little more complete if I made that statement. So I could have done that here with ZY, W, and XWY. They are alternate interior angles by the definition of alternate interior angles. And then I can apply Theorem 12.1. I'm just going to jump right into Theorem 12.1, though, once again. So now that I know that they're congruent, I'm going to state that AD is parallel to BC by Theorem 12.1. Okay, that's the converse of the alternate interior angles theorem. And now, wait a second, I know that we have congruent opposite sides, and those congruent opposite sides are parallel, so I could state ABCD is a parallelogram by the properties of parallelograms. And that's going to be parallel, congruent, opposite sides. All right, that's letter D. And then finally on to letter E. In letter E, we have a railing on the front of a staircase. I guess it's on a front staircase. And if angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4, prove that the top railing and the bottom railing are parallel. Okay, so I know angle 1 and angle 2 are congruent. Angle 3 and angle 4 are congruent. Here's how I'm going to do this one. Number 1, we're going to state that this one's a little different, so pay attention to this. We're going to state that, and what I would do is I would put like E, F, G, H on here, and I would make it a given that E, F, G, H is the parallelogram that we're dealing with. Let me just go ahead and do that quickly, because this is going to be really hard without being able to name my parallelogram. So we're going to do E, we're going to do F. By the way, feel free that you can always just add letters to the vertices of these real-world proofs. Sometimes it would just be better if they put them in for you. Okay, E, F, G, and then H down here. So these are going to be the vertices of my parallelogram. So what I'm going to state is that angle, let's see, and I'm told that the angles are, so I can just, so I would state that angle 1, angle 2 are congruent, angle 3, angle 4 are congruent. So what I could state is that EFGH is a parallelogram by the properties of parallelograms. And then I'm going to note in parentheses which one I'm using. This is congruent opposite angles, okay? And then how do I state that the top and bottom rails are parallel? EF is parallel to GH. How would I do that? By the definition of a parallelogram. Because I know by the definition of parallelogram, they have to have parallel opposite sides. So that hasn't come up yet. I'm glad it came up in that last problem, because once you prove that something is a parallelogram, you can also apply the definition of parallelogram to make statements about it. That's how you do these. These aren't too hard, are they? They're pretty straightforward problems, and I expect that you're going to be able to do them. Now you're able to work numbers 1 through 34 next time.